This next one here, we have a circle. It's tangent at AD and AB, okay, and a DC as well. It says that AB passes through the midpoint of AC. So AB, so AD and AB pass through the midpoint of A to C. Circle tangent, okay. So this is going to be drawn like this. Okay, so A to C. Okay, and that tangent point, that tangent circle passes through the midpoint, so halfway here and halfway here. Okay, so it says find the radius of the circle as A to B is 12. So if we can imagine the symmetry involved in this, we can figure out this problem without having to do any trig. So if I know that this is a midpoint here, okay, so that line must represent the midpoint, this is going to split this into two parts. So this is basically going to be able to fit two exact circles into this rectangle. And that means then that if I want to find out the radius of the circle, the radius is going to be this length, R, this length, R, this length, R, this length, R. So we can just say using, and again, all I've done is use symmetry here. 4R is equal to 12, so my radius is equal to 3. Okay. I could try to use some trig here and work this out, but this is probably easier just to do it in that way. So for the area of the shaded sector, what we need to figure out is the angle, and this is where we're going to have to use some trig. So we need to figure out this angle in here, we'll call theta. Okay. So how do I find that angle theta? Well, I've established that this is the radius, 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 radius. So we also know that this is a radius. And using this triangle here, I'm just going to outline this triangle in blue. We don't really need the line. That line from the center to C, the diagonal line, is awkward. But the line along the horizontal is going to be easy to measure because we know that's going to be 3R. And then we can work out this angle based on the ratio of these sides. We could work out the third side as well, but we don't really need to because we can use the ratio of these two sides to get the shape. In fact, the same shape as the last problem we just did. So in this case here, I know that my tan of angle theta is equal to the opposite over the adjacent, okay, which simplifies to just 3. And so I can work out that angle. So we had 18 point something here when we worked it out from this perspective. So this should be about 71 point something, close to 72 degrees. So I need to undo this tan. So I need to use arctan to get my angle. Okay, so my ratio is my input, my output is my angle. And as I type this into my calculator, inverse tan of 3 gives me 71.565, so I'm going to round that to 57 degrees. So given that angle now, we can solve for the area of that circle. Okay, so just to double check here, this should relate to that last problem, yeah? 18.43, 71.57, they are complementary to each other, meaning they add up to 90 degrees, okay, because they are actually the same triangle. So to find out the area of the sector, what we need to do is first of all find out the area of the circle. Area of the circle is pi r squared. Okay, so pi times the radius worked out to be 3 pi r squared, so we end up with 9 pi units squared. Or in this case, I think it was centimeters. Centimeters squared. Okay, so there's my area. That's about close to 30 centimeters squared, if I work out the decimal. And I want just a fraction of this circle. So the fraction of the circle is going to be determined by the ratio of the angle 71.57 degrees divided by 360. This is how I always get a fraction, how I determine the fraction of the full circle. I compare the part angle 71.57 divided by the whole angle, which is 360 degrees. I multiply then that by the total area, and this gives me the area, the shaded fraction that I wanted. So I'm going to do 71.57 divided by 360, which is about close to 20%. And then I'm going to times that by 9 pi. So I'm going to get about 5.62 centimeters squared. Okay, and again, we might be off a little bit with our decimals because of the rounding, but we should be pretty close to about 5.5. Okay, so that's the area of that shaded sector.